In this session, we are going to discuss the new topic about the scaler, how we can control our scaler, and without scaler, how we can uh, we do make the decision uh, uh, directly for some host for the pod. My cluster is up and running, and if I look into kubectl get. So in the cube system namespace, uh, my scalar as a static pod is uh, running. So I will disable this scalar, and the static pods in the Kubernetes are residing under this location. So if we remove this manifest from this path, it will be stopped. So let me move this scalar manifest to somewhere else. Now it's not there. And now if I fetch the information of the static parts in the cube system namespace, you can see the scalar is turned off. It's not running here. So we have API server is up and running. That's why we are interacting with the cluster. Controller manager is running, and the core DNS and etcd. So these components are running, but scalar is not there. Now I will send a request to API to create some resource. For example, a typical pod I am going to create. If I go to my manifests, there are manifests for, I believe, if I just quickly take a look on this manifest. So this contains persistent volume 2. I will not use this. Anyone very simple. This is very simple. So this is some pod will run having name app3. It is using Tomcat, okay, and it will run. So under the dev namespaces, we'll try to set up this pod resource. So in the dev, you can see the app3. These were already running. So you will see that this is in the pending state. And why this is in the pending state, if I look into the so there is no event so far, because the very first event happening is the request is going to API send asked from Scalar that where should I host it? And API is looking for the acknowledgement of the Scalar, and that is not coming back. So that's why it will remain in the pending state. Okay. So if your scalar is not running, you cannot get the information. You cannot schedule your resources, pod resource. You can set up your uh, config map, secret, any other thing, but pods will not be scheduled. So you can see it's in the pending state. I can provide manually this pod to be scheduled on some host. So if you remember, we had a detailed discussion on the pod on some specific nodes where we look into the node port, node selector, taint, and affinity, anti-affinity. So those things we can use based on label or node name or affinity based, we can make a decision that where this pod should uh, be selected. But the node name and node name and the label based decision will bypass the scaler. Whenever the request we will send to API, it will not ask from the API, from the scheduler. It will directly look what host contain these information, and it will directly send those pods for the hosting purpose. So now I will delete this pod and I will edit this pod, and I have to define here node name and the node name, for example, worker one. So I define the node name and it will be go here. So in this case, when I will apply, you can see this container creating in the decision has been made where it will be scheduled. And it is scheduled on worker node one. App 2, I believe it was. No, this one. Okay. So if I open this manifest, yeah, it is containing two images, two containers. That's why it's showing me two. So this was the way you can bypass the scheduler. Okay, next thing is how we can upgrade the version of our cluster. If we look into kubectl nodes, so you can see our cluster variant is 1.28 and minor variant is 10. If we run kubectl upgrade plan, kubectl upgrade plan, I believe there was update. Just let me take a look on the -help. There was some sorry, I forget about that. Just leave it. But upgrade plan, I explain you in another video. So what I can see, the variant is 1.28, and the latest variant nowadays is 1.30. I know. So I will upgrade my cluster gradually, one by one host. So any host I can decide and I can apply the upgrade. In Kubernetes cluster, it is possible that your master node or any worker node is on the higher version and has to follow on the lower version. It will work. I think there is some specific level of version limitations that cannot go beyond the other worker nodes. But among 1.28 and 3.0, it is working. Let me first of all isolate any worker node from this cluster. So how can we can isolate? We did a session for the uh, cordon and evacuation. So what I will do, first of all, let me check kubectl, kubectl get pod -a and -o wide. So I can see worker 2, worker 1, worker 2 are having different pods running. Okay, so let me drain worker 2. And when I will do a drain, it will give me error that the daemon sets running will not be drained. Unable to drain. Okay, error cannot delete pod, declare error controller use. Yes, enforce or use to ignore. So I don't want to drain the daemon sets. Daemon sets are mostly are running. I know it's based for the Calico, and it's for some monitoring purpose it could be. So if those pods are unsaved, disconnected from the cluster, that will not make an issue. I'm just training worker node 2. It is still giving me error to override. There are pending nodes to be trained. Let me get the nodes. Yes, it is done. And when we are doing the drain, the cordon is already happened. The concept of drain and cordon we discussed in very detail in our previous videos. So now nothing will be scheduled on this one. So if I get the pods, all namespace, -o wide, and I do the grab to this worker node 2, I should get, yeah, I think I need to also use, it is cordon, but I also need to use force. So all the pods that are running on this host are evacuated. If I run now, only you can see the daemon set related pods are running, but my application workload is removed from this worker node. And if those pods are running under some replica set or deployment or stateful set, so these are controlled by the controller manager, and the controller manager will reschedule it on another healthy worker node. But no new load will come on this worker node. So now I will go to this worker node. If I do -o wide, I can see the worker node 2 contains this IP. I jump onto this node, and here, first of all, I will stop the kubelet service. The kubelet service we discussed, this is the core engine on any or all the nodes that are making communication to API server about the health of the nodes. So since I stopped it, I look the status. So you can see if this is stopped, inactive. Okay. it is stopped. So let me go back to my master node. Query to nodes. So you can see when it is stopped, the status reported to not ready. Okay, so this node is not ready and not scheduled for the no load will go there. So now I will again jump to my worker node 3, and I have to look for the packages that we installed during the very first session we did about the installation of the Kubernetes cluster. So apt list installed is the command in Kubernetes in Ubuntu. It will list us all the currently installed packages along with their variant number. And if I do a grep to kube, starting the packages with the name kube. So you know the kubelet, the kube-adam, the kube-ctl, and the Kubernetes CNI we installed. And their version number is also mentioned here. Okay, so right now this command is suggesting me you have variant 10, minor variant 10, 1.28 major variant, and you can upgrade to version 11. Why it is saying? Because when I install this cluster, so if I go to my GitHub, so in this virtual university, we create this. So all these documents I uploaded here, and here you can see the bootstrap of a Kubernetes cluster, and script is also given here. So in the bootstrapping, if you look into the step number 4, step number 4, where I install these packages, and I enable with these two commands the repository of Kubernetes to pull down the relevant images. So actually in this file, what we did, we defined the variant number of our repo we have to use to pull down. So the URL we gave package ARK8SIO core stable variant v1.28. So we can change this v1.28 with 1.30. So I want to update to latest one, so I'm changing to this 30. I'm not doing this blindly. Actually, I first of all check online what latest repository is available. And then in the second step, we pull down the relevant GPG key for these packages, these repositories. So I need to do this again for variant 1.30 because that GPG key we pull down for 1.28. So let me run this again. It's asking that you already have a GPG key. Okay, I want to override it. It's done. Now I will do apt update, and it will fetch the new repository that should work. Yes, you can see these are This is a new repository version 1.30. So I updated my repository successfully. Now I will again do the query and apt list installed. And it will suggest me now the latest version need to. So I'm going to query again with the same thing, and this time it is suggesting me you can update to version this level. So latest version of 1.30, minor version of 30 is 2-11. Okay. So this in now we can directly jump to this version. Okay, very good. Now how we can do this? So if we go back to the documentation, what after activating this repository, we disable the swap and we install these packages. And I also mentioned here, if you have some specific variant, you can define that variant number with equals. Okay, so I will do apt install kube-adam equals to this one. kubectl we don't need on worker node, but we just installed in case if we need to do administration. In some case, if we have the kube config file on any worker node, we can do this, but this is not the imperative for worker nodes. For worker nodes, kube-adam and kubelet is important. So I am defining this way. And -y I will do automatically yes selection. Okay, it is done. I think one step more we need to do. Actually, you can get the issue of the hold. When we set up the cluster, we hold, but I don't know why this was unhold. I think I did some exercise, that's why it's unhold. So these packages, when you will installed by this documentation, these packages are on hold, mean no one can uninstall it. So you must have to do unhold before this installation step. But it was already unhold. That's why I have not got this error. So I will do again the hold. Okay, mean no one now can change and uninstall these packages. So now I will list. You can see the latest version of these packages are installed. Now I need to start the kubelet. Check the status. So all the configuration files are intact, and if any configuration changes in the new version, it is applied, but the configurations are as it is, and it is active. Now let me see if this is communicating with our master node. So from my master node, I'm back to my master node. I will run get node, and you can see it's ready. And its version is updated to this level. Okay, so we have successfully updated. It is still scheduling disabled, so I will do kubectl uncordon this worker node. It's uncalled, and now the latest version of this worker node is available to maintain the load. Just for the testing purpose, I will apply some load. Deployment has only one replica. Change replicas to 6. And I will apply this. It will distribute the load among the different nodes. I believe it was in the tab namespace. So worker node, so far it's trying to schedule. It's in the pending state. What's the reason? Because my schedule is still down. It will remain in the pending state. So I need to go back and in the Kubernetes manifest. One step back, I throw this scheduler file. I will put it back here and kube-scheduler get kube system, and a kube-scheduler is back to work. Now I will get status of these pods. As the scheduler came back, it acknowledged to API, get all the information and acknowledge back to API that you can schedule there. So you can see in the worker node 2, 1, 2, 1, 2, but different, equally low host load is divided. So, and our node is updated. Same you can apply for all the other worker node gradually. So this could be a planned downtime or unplanned downtime, depends on the criticality of your application. If your critical applications are running on that specific worker node, when you will do the drain, so it will take a while to restart or recreate the pods on some other worker node. That will be a downtime, but all the users that are getting information from that specific pod will be disturbed. So definitely it's a planned downtime, and you need to do this activity in the off hours, or if you have some application that is critical and 24/7 up and running. So that will be a planned downtime. So this was the topic for our current session, and you can apply this for worker node 1. Same you can do on the master node. So if your master node is down, it will not affect the health of your cluster. I mean, you cannot interact with the API, you cannot schedule anything, you cannot take the leverage of controller manager of auto healing. Okay, your etcd database is down, but your workload will remain up and running. On your applications on the worker nodes will remain up and running. Okay, so you can do with very safe way the downtime of your master node, and you can do upgrade. You can apply the upgrade with the same way. So in next session, we have to discuss the role-based access control and concept of contacts and a lot of other concepts related to what type of service accounts. So how we can limit the access to our cluster for different users. So far, what I am using, it's the full administrative access API, the Kube API config file provided me by the cluster at the time of setting up this cluster. So we will see this in detail.